All right. We are now looking at page 82. And this is all about multiplying. So it's what did they say about the man who drank shellac? And then do each exercise below and find your answer. Instead of answers to the right of that exercise, write the letter of your answer in the box containing the number of that exercise. All right, so this is multiplying binomials. I hope we can remember this from last year. So it's x plus 4, x plus 2. All right, and this is where you have to distribute twice. A lot of people thinking learn probably FOIL, or I also make the smiley face, so you might learn it either of those ways. So if you're thinking it's your first term, so x times x is x squared. Your outside terms, so x times 2 is 2x. Your inside terms, and then your last terms. I think about this little smiley face dude. I don't know, it kind of looks like a little man. Or it's first, outside, inside, fast. Right? F-O-I-L. FOIL method. Okay. So then we just have to combine these two because they're like terms. So we get x squared plus 6x plus 8. So we have h for number 1. And this is another one where we're just going down and then writing the letter below. All right, we're going to look at number 7 as well. Just one more. We have 2u plus 4 times u plus 1. So again, first, outside. 2u times 1 is 2u. Inside, and last. Again, we have to combine these. So we get 2u squared plus 6u plus 4. 6u plus 4. So number 7 is L. We're actually going to do one more. I'm going to do one of these on the bottom. So let's do subtraction. Let's do 14. So we have 3x minus y times 8x minus y. First, 3x times 8x, so 3 times 8 is 24. X times x is x squared. Outside, 3x times negative y, well, a positive times a negative is negative 3x y, right? So anytime you have two variables, you just write them next to each other. You can't really multiply them. And we always go in alphabetical order, so x, y. So same thing when I do negative y times 8x. Again, it's negative 8 and then x, y, purely because x comes first in the alphabet. And then negative y times negative y. A negative times a negative is positive y squared. Okay? And then these are like terms. So you get 24x squared minus 11xy plus y squared. 24x minus 11xy plus y squared. Yes, no, I. So that's number 14 is an I. All right, go ahead, pause the video and do the rest of those problems. All right, looking at our next page, page 84. This first section is telling you to multiply, and the second section is telling you to factor. Okay? So why didn't Klutz do any homework on Saturday? Either multiply or factor as directed and find the answer in the adjacent column. Alright, this section is all about difference of squares. And difference of squares, it can go either way depending on if you're multiplying or factoring. And it's something that looks like a plus b. Right, so they're the same except one's positive and one's negative. And it comes out to something that looks like this. Don't need the parentheses, but that's okay. Right? So if I'm multiplying two things, it's going to look like that. If I'm factoring, I'll start with this and go that way. Okay? Right, so this first section is multiplying, so I guess this is letter I is actually what we're doing here. So I have a plus 5 times a minus 5. And with that, I get a squared, right? Outside is minus 5a. Inside is plus 5a, and then 5 times negative 5 is minus 25. Okay, so this is where this part comes from. A plus b, a minus b goes to that. So if you notice, right, a squared, this and this are opposites. Negative 5a plus 5a is just 0, minus 25. So we get something that looks like that. So that is a squared minus 25 to 6. So number 6 is I. Okay. Alright, we're also going to look at this letter I. 4x squared minus 49y squared. Okay, so now we have to recognize that this is a difference of squares. On this activity, they're all difference of squares, so it's easy to recognize. But on later activities, it just throws all the types of factoring that we're going to be doing at you, and so you'll have to recognize when you have difference of squares. Okay. So I have difference of squares if this is a perfect square and this is a perfect square. I know this is a perfect square because 4 is and 2 is even. Okay, as long as the exponent is even, then it's a perfect square. This number actually has to be a perfect square. Okay? So then all you're doing is taking the square root. The square root of 4x is 2x, and the square root of 49y squared is 7y. And you simply write it as minus, and then plus, or plus then minus, the order doesn't matter. But these have two different signs. So you have 2x plus 7y, 2x minus 7y. I guess they're doing plus first, so I will continue to do plus first. So 22 is letter I. We're going to do letter E next. On this one. Just make it an easier problem. Probably should have switched the order of those. But n squared minus 49. Right? Same type of thing. I know n squared, that's even. 49 is a perfect square. So the square root of n squared is n. Square root of 49 is 7. And then just write it again with your other operation, other sign. Then let's do a weird one like letter D. We get a weird one in. We're doing this one. 16. Again, 16 is a perfect square, and these are both even. So the square root of 16 is 4. And the square root of a to the 4th, b to the 6th. The reason you have to have it be even, because the square root of an exponent is really just cutting it in half. So the square root of a to the 4th is a squared, and the square root of b to the 6th is b cubed. And then same thing. Another reason I like this one is because this one doesn't have a variable first, but that's okay. Whatever comes first here, when I take the square root, needs to come first as well. So it's 4 plus a squared b cubed, 4 minus a squared b cubed. So that's 19. All right, go ahead and pause the video. And then work on the rest of these problems. All right, we are now going to look at our next page. So in our last one, we looked at difference of squares. And for this activity, we're going to look at a different type of what we call special case. And it is called perfect squares. So if you have something, I'm looking at the first question, but I don't want to look at the first question. I want to just do a general case, all right? A plus b squared. When you multiply that out, all right, and again, this arrow goes both ways. If I was to multiply that out, you get a squared plus 2ab plus b squared, and then you like simplify that. And then if you start with something that looks like this, then you can go to something that looks like that. Okay? So we're going to look at this letter E first. Alright, so this whole area is just expressing as a trinomial, you're multiplying it out. Let me give myself a little more room to work over here. Get that letter E. So I have u plus 3 squared. Alright, you could just use this. I first just want to show how we get this. Alright, it's from just multiplying. Remember, squaring something is multiplying it by itself. So u plus 3 squared is really the same as u plus 3 times u plus 3. And then we distribute, right? So that's u squared plus 3u. Right. So if you look here, I have the squared and this squared, right? 3 squared, which is our b here. And then 2ab. So I have ab, right? That represents what was here. And I have 2 of them. So that's really where that 2ab comes from. Okay. So then u squared plus 6u plus 9. So I go down to the bottom and look for that, which is 9. So number 9 is E. Alright, I'm going to show 2 ways to do these basic problems. So we're going to look at also this letter E.
O.
Alright.
A. O.
We're also going to look at this other letter E for factoring. I'm going to show, so we always have to check first to see if it can be factored using this method. So what we do is we take the first one and square root it, just like we did before. Okay. We take the second one and we square root it. And then, I don't know why that looks weird. We have to check if the middle is this part, that 2ab times t times 2 equals, well, 2 times 2 is 4t. Check. Okay, so we take it, square root it, we take it, square root it, and then we're just checking to see if this actually is 2ab. If it's not, then you can't factor it. If it is, you just write it as the first one plus the second one squared. Okay. So then it looks like 15. So when we go down here, that's also the letter E under 15. Right, and E. Fine. Alright, next we are going to look at letter S. So same type of thing. We have now 9t squared minus 12t plus 4. So the square root of, getting ahead of myself, 9t squared. The square root of 9 is 3. The square root of t squared is t. The square root of 4. So now I want to check 2 times 3. 2 times 3t times 2 is 12t. Then the next thing I always have to look at is the sign. I forgot to mention this one because it was positive, so it didn't even cross my mind. This was positive, so this was t plus 2. This one is negative. So that means it's the first one minus the second one squared. So this sign determines what this sign is. Okay, only that sign in front of this middle thing here. So that's 3t minus 2 squared. So that's 21 is S. All right, last one we're going to look at is H. So this is one that has both an A and a B. And I'm actually going to move it down just a little bit more. And we have a squared plus so we take our first one, the square root of a squared, the square root of 25 b squared. Again, the square root of 25 is 5. The square root of b squared is b. So then we have to check 2 times a times 5b. Again, we just take all our numbers. 2 times 5 is 10. A, b, we just write in alphabetical order. So that does check out. Okay, so all of these checked out for us. This is positive, so it's a plus 5b squared. And that's 14, so 14 is an H. All right, go ahead and pause the video and work on the rest of those. All right, we'll now be looking at page 87, and page 87 tells us factor completely each polynomial below. Find your answer, and notice the 2 letters next to it. Write these letters in the 2 boxes. So for this one, it is a mix of the last 2 things we just did. So it might be a perfect square, and it might be difference of squares, so you have to know the difference between the 2. And it also might have a greatest common factor, or it will have a greatest common factor. Okay? So let's look at our first one. We're going to look at number 1 first. So the first thing I'm looking at is what my common factor, or greatest common factor, is between these, what I can take out of both of them. And both of these can be divided by 3. So really we are dividing by 3, but since it's not equal to anything, that 3 can't go away. It just goes out in front. Then there's only 2 numbers here, and x squared and 25 are both perfect squares. So I'm taking the square root of both of them, right? Because this is the difference of squares. Should have brought left room. Okay. So then remember we have the x plus 5 and x minus 5. That's just like what we did on page 84. Okay. So we're going to look for that answer, and that is HE. So number 1 has HE, I guess. Oh, it doesn't give HE. It's H and then E. All right. We're also going to look at number 2. Okay. Number 2 is 5x squared plus 30x plus 45. Again, these all have a 5 that can be divided out of them. So 5 goes on the outside, and we have x squared plus 6x plus 9. Now this is a perfect square trinomial, or we can check to see if it is. So I'm going to do the square root of x squared is x. The square root of 9 is 3. Do our check. 2 times x times 3 equals 6x. That matches. It's positive. Our 5 still has to go on the outside, and we have x plus 3 squared. So we look here, number 2 is SF. The next one we're going to look at is number 5. So I'm going to scroll this down. So if I look, both of these have a 2 in them, but they also both have a k in them. So that's what I'm taking out of both of those. Okay. So 2k goes on the outside. I'm left with k squared minus 4. That makes this difference of squares. If we tried before we divided that out, right, I can't take the square root of 8, so it wouldn't work. So we really want to make sure we look for those greatest common factors first. Now I'm doing the square root of k squared. Okay, square root of 4 equals 2. 2k still goes on the outside. This is difference of squares, so it goes to k plus 2, k minus 2. HE. Oh my god, another HE for number 5. And then the last one we're going to look at is number 10. So, again, we have to take out our greatest common factor. I see they all can be divided by 2. They also all have a b squared in them. So I'm left with 16a squared. Got to write it on the outside. 16a squared plus 8a plus 1. Doing my square roots, the square root of 16a squared is 4a. The square root of 1 is 1. Check. 2 times 4a times 1 is 8a. It's positive, so that will be, again, the outside has to remain outside, 2b squared. 4a plus 1 from here. Squared. b squared, 4a plus 1 squared. IN. Alright, and that is it. Go ahead, pause the video, go and work on the next section.